Hello students, welcome back to my channel, and today in our uppercut we are going to discuss a very important quicker concept. This concept is very important and is often asked in your exams. So I'll suggest don't miss this concept. Let's discuss the concept. The concept for today in our uppercut is to distinguish between the concentrated and dilute sulfuric acid using a single reagent. So we'll be using a single reagent to distinguish between concentrated and dilute sulfuric acid. I'm making this video because most of the time I get questions from my students that is there any difference between concentrated and dilute sulfuric acid, and if there is any, how they behave differently. So let's discuss this concept in detail. To discuss this concept, we are going to take a single reagent, and that single reagent can be pure potassium iodide or sodium iodide. You can take either of them. We'll start with taking potassium iodide. So let's see how it goes. So reaction of potassium iodide with Conc H2SO4. So here, if we take Conc H2SO4 and treat this with potassium iodide, let's see how the reaction goes. So if we take Ki, the potassium iodide salt, and treat it with H2SO4, and we have taken hot and Conc H2SO4. So the reaction follows like this. Through double displacement reaction, it will be K2SO4 and HI are formed. Now this HI further reacts with Conc H2SO4 because we are taking Conc H2SO4 in excess here. So this HI further reacts with H2SO4 to give SO2 plus I2 plus H2O. So H2O is produced along with SO2 and I2 are produced. So this SO2 is a colorless gas and this I2 gives purple vapors. So this purple vapor confirms the chemical change. So Ki, when reacted with excess of H2SO4, it produces purple vapor along with SO2 and H2. Now, we have already discussed the hydrogen iodide initially formed by double displacement is readily oxidized to free iodine. So here oxidation reaction is taking place in which Hi is getting oxidized to free iodine. Okay, now let's discuss what happens if bromide salt is used. So previously we used iodide salt, now you'll be using bromide salt. So in case of bromide salt, we can again take sodium bromide or potassium bromide. And when you take a bromide salt, the reaction follows the same chain of steps with the only difference that this time orange brown vapors instead of purple vapors are produced. So we can write how the reaction follows. Let's for our convenience take KBr and treat this with H2SO4 Conc. What it gives? It will produce this in the similar fashion K2SO4 plus HBr. HBr further will be oxidized in the presence of excess of H2SO4 to give SO2 plus Br2 plus H2O. So the reaction follows the same suits with the only difference that this time bromide is produced instead of iodide, and this bromide is orange brown in color, and again SO2 will be colorless. So this orange brown color confirms the formation of bromide in the reaction. Now, what we conclude here, both HBr and HI are strong reducing agents. Yes, are strong reducing agent because they are getting oxidized, so they are easily oxidized to free bromine and iodine respectively by hot Conc H2SO4. So this is a very important concept that you have to remember. Now, coming back to what happens if chloride salt is used. So we have already used bromide salt and iodide salt. Now we'll see what happens when we take chloride salt. So again we'll take, for our convenience, KCl plus H2SO4, and H2SO4 will be Conc. Now this reaction will proceed like K2SO4 and produce HCl. Now this HCl being a mild reducing agent, is not oxidized by hot Conc H2SO4 like it was happening for bromide and iodide salts. So this is again a very important concept, that HCl is a mild reducing agent and it will not give a similar reaction, like it will not produce Cl2, chlorine gas, like it was producing Br2 and I2. So Cl2 will not be produced here. So this is another concept that you have to remember, that KCl, KBr and Ki, the differences they exhibit. Now reaction with potassium iodide with dilute H2SO4. So as far as now we have discussed various salts with Conc H2SO4. Now we'll see similar reactions with dilute H2SO4. So when we treat a potassium iodide salt with H2SO4, that is dilute, this time we are taking dilute H2SO4, it will not produce any visible chemical change, and that confirms that Conc H2SO4 and dilute H2SO4 behaves differently. So dilute H2SO4 does not produce any visible chemical change with the iodide salt, as it is non-oxidizing. So you can take again iodide, bromide salt or chloride salt, will not be any visible change. That's how dilute H2SO4 and Conc H2SO4 are different. Now we'll focus on what are the outcomes of this video. So learning outcomes are, the first thing is hot Conc H2SO4 is moderately strong oxidizing agent, while dilute H2SO4 is a non-oxidizing agent, and this is the difference that we sought while starting this video. So this concept is very important, you have to remember it. There are times when questions are directly asked on this concept, so it is a very important concept to remember. Again, what are the free hits? So free hits are the byproducts of any concept we discuss under our uppercut tutorials. So the first free hit is color. So color, you can see that purple vapors are iodine. Iodine has purple vapor, you can remember this. Again, bromine is orange brown in color, so it may be asked sometimes, so you have to remember this. Sulfur dioxide is a colorless gas. So 3 colors of gases you can remember through this video. Again, a very important concept, HBr and HI are strong reducing agent that we already discussed previously, while HCl is a mild reducing agent. So whatever outcomes that we have produced here, you have to remember them. They are very important. Hope you like this video. This is all for today. We'll come with another such great topic in our uppercut section in the next video. Till then, thank you so much. Enjoy. Bye bye.